Welcome to this poster presentation. My name is Gonçalo Vieira, and I'm presenting you the more recent results from the mapping and monitoring of exposure to flooding and coastal erosion in a couple of communities, two communities in the Beaufort Sea coast in the Western Canadian Arctic. I'm going to show the results of monitoring done using drones, essentially photogrammetric grade drones with optical cameras, but we are coupling this imagery that we are acquiring also with very high resolution surveys using multispectral satellites and also high resolution satellite imagery. So we are using the UAVs for obtaining these very precise and also accurate orthomosaics and also digital surface models. We are working on two communities close to the coast, two coastal communities. One of these communities is Tuktoyaktuk, and the other community is Polotak, some 300 kilometers east of Tuktoyaktuk. So we are located here in the Beaufort Sea coast. It's an area where the Arctic Ocean has been changing quite fast, and erosion has been increasing substantially, including also more events of storms and storm surges, which affect these communities by increasing erosion and also flooding. The examples I'm going to provide are related to the work we have been doing in Tuktoyaktuk in close cooperation with Natural Resources Canada, the Geological Survey of Canada, a team led by Dustin Whalen, which has been working for several years in the area, and there's very close links with the Hamlet of Tuktoyaktuk, with whom these projects are also collaborating. I would like to emphasize on the importance of co-design and co-production of knowledge. So together with local communities, we better plan for the research we are doing. We also better design the research plans, and of course we work better in the field together with the community. So in 2018 and 2019 in the summers we did the complete UAV surveys of the hamlet. We also conducted surveys of the infrastructure and past flooding in cooperation with the hamlet, and we are currently conducting flood modeling using different scenarios. These images show you a bit of the flavor of what we are getting. Very high resolution orthomosaics with 10 centimeter resolution, very accurate survey of the infrastructure, coastal exposure of the areas, and currently we are working with flood models using different storm surge levels and also different scenarios for sea level rise. This is based in field surveys with the drones, but also on collection of GNSS points in differential mode, and on surveys of the past flood levels, which are used to validate the models which we are developing, which are quite detailed. They also include some drainage infrastructure, which allow to much better assess the knowledge. So we are currently comparing LiDAR surveys with our drone surveys, and we are obtaining the first results. These activities are also being conducted with a slightly different approach in Polotak, but I have focused essentially in Polotak for this talk. So as a final remark, I would like to mention that UAVs allow for this unprecedented data that may be used as ground truthing for satellite imagery, as has been shown by several of our colleagues. The synergistic use of different remote sensing platforms, linking field-based remote sensing and also the satellite observations, allow for very high accuracy monitoring of coastal changes and impacts. Finally, we are now addressing environmental issues at remote locations in ways that were not possible before. And finally, I would like to emphasize on the importance of co-designed and collaborative approaches, which allow us to better tackle local issues and bring science much closer to the population. Thank you very much for your interest.